Hello YouTube, we're back. Here's part 2 of midterm week screencasts about how to tweak your computers for math class. The last screencast was about setting up your student computers. Here they are. And now let's talk about setting up a smartboard user and a screencasting user on the teacher PC. All right, so that's what this is about. So I created another user called Shadowfax on Legolas. By the way, don't worry, it's not weird that we name our computers, okay? Legolas is the name of the computer and Shadowfax is a user. That's okay. We did so by adding a user this way, and we protected the security of the data for that user this way. And now Shadowfax will be my teacher or smartboard user. I use it for screencasting as well. So I'll show you how I set that all up and see the video above. If the video isn't here yet, because I'm recording it now, you'll see it. Of course, you're seeing it now, so there you go. Then we installed the JRE as a Firefox plugin so that screencast-o-matic could work for screencasting. You get that here. Okay, I used this option for Ubuntu Linux, and these instructions are very easy to follow. That lets you get screencast-o-matic working nice as a screencaster. I also wanted to get keepvid.com running, but it doesn't like JRE.1.7 for some reason, so it's not working out. I like screencast-o-matic, but I'm using avconf right now. I used screencast-o-matic on the last recording, but avconf is nice in that it renders as you record. So when you're done recording, the video is ready right away. With screencast-o-matic on the last video, for example, it was only 16 minutes long, but screencast-o-matic took over 8 minutes to render it as an MP4 file at 55 megabytes. That's a little bit inefficient, I don't know. But it's there as a backup if you need it. Another nice thing about screencast-o-matic is you can see my mouse. I don't know if you can see my mouse right now. I'm circling around screencast-o-matic. It highlights it in screencast-o-matic. It doesn't highlight that in avconf, but there you go. What else? Download the latest version of Smart Notebook. Here's instructions for installing it. You have to do it in a very special order, and you can get some utilities from the Ubuntu Software Center that you need, Next Window, and libudev0. And by the way, the first time you run Smart Notebook, you better have your product key. Then I installed Chrome from here. Okay, and pick your operating system, pick your architecture, you know, Windows or Linux, 64-bit or 32-bit, whatever. I'm running 32-bit right now because Smart Notebook doesn't run in 64-bit. And Chrome is nice for eSchool. And so see, if I go to Chrome, you got eSchool right there, see? Now I'm back to Firefox. I also installed Ubuntu Restricted Extras, so that gives you a whole bunch of stuff, including Flash and libDVD-free 4, which makes it easy to play DVDs in VLC. So then I installed VLC from the Ubuntu Software Center. I also installed libav-tools, which gives you avconf, which is the screencaster I'm using right now. A lot easier to use than FFmpeg. Then I installed TeamViewer and SplashTop. I'm using TeamViewer right now because SplashTop costs extra to use behind a firewall. So I'm using TeamViewer, and what's nice about this is it's a mirroring app that's great for controlling your desktop and smartboard remotely from a tablet. It could be an iPad, it could be a Droid tablet. I'm using Kindle Fire HD right now, 9-inch. Then I installed Zernal because sometimes you don't want to use Smart Notebook, as you'll see in a minute. Zernal does everything I need it to do. I can draw on it my math equations and whatnot. I can save it to a file. I can share it with my students on Dropbox or what have you. I also installed Dropbox, as you can see right here. Smart Notebook is a memory hog, so it's a little laggy when I run it in combination. Let's see, here it is. When I use Zernal in combination with either Screencaster plus TeamViewer, the system responds. Wait, I messed up. Sorry. When I use Smart Notebook in combination with either Screencaster plus TeamViewer, the system is very laggy. But when I use Zernal in combination with either Screencaster and TeamViewer, the system response is better. And by the way, if you use SplashTop, it's an even better response when you're drawing on the tablet. It's nice and smooth. So note the following work together: my Bluetooth or USB mic, avconf or screencast-o-matic, Zernal or Smart Notebook, TeamViewer or Splashtop, and the tablet or the smartboard. In Linux, I prefer using the Bluetooth mic. I'm using that right now. AVComp, I'm using it right now. Xernal, I'm going to use right now. TeamViewer, I'm going to start up right now. And the smartboard, but I'll show you how the droid works. So I'm going to put the droid here. When I'm on the road, I usually stuck with Windows, and I can't set up anything in advance, so it's quick and easy setup is my USB mic, screencast-o-matic is online, Smart Notebook is already installed. If not, I'll use Xernal from my USB stick. I have a Windows version. And Splashtop if it's installed, otherwise we'll use TeamViewer also from a USB stick, and my tablet. There you go. So let's do some stuff. Let's see, here's Xernal. And Xernal's nice in that I can, use it sort of like a Smart Notebook. I can export to PDF and share files just like I do with Smart Notebook. I don't really use a lot of bells and whistles otherwise in Smart Notebook, so this is fine. And then here's TeamViewer. And TeamViewer, what it does is it gives you, this is what's called the desktop streamer. You need the Droid client as well. And so what I'm going to do is I'm going to type in this code into my client. Now you don't see my Droid, you're just seeing my desktop obviously, but okay. And then click Remote Control, and it asks you for a password. Now this code doesn't change from day to day on the PC, on a given PC, but this will change each time. So I got to type that in. 994. Okay, and let's see if it connects. And there it is. That means it connected, and now I see on my Droid the exact same thing you see on the desktop. This whole desktop. What's nice with this though is I can use one finger to draw. Let's say like this, if I want to draw. Okay, whatever I'm doing. Oh, note I have on here, I have pen as a default. I have shape recognizer as default, so lines come out nice. Circles should come out nice too. Wait, let's try that again. Let's try another page. How about, here's a circle. No, that was a mess. What happened there? Here's a circle. Why isn't it working? What's going on? Alrighty, hang on. We're having technical difficulties. All right, what I think what happened is it's easier to work with two fingers. I can either pinch my fingers or separate my fingers and zoom in where I want to be writing, and then it comes out nicer. Now I'm doing this with my fingers, so here's a triangle. Let's see. There you go. Here's a circle. There you go. Here's a line. See the idea? There you go. Nice. Now, you see this is the top left-hand corner of Xernal page, or my students will see the same thing on the smartboard, but I only see these three objects. If I want to write anywhere else, I'm going to need three fingers to slide over, and then I can do stuff over here. Let's say whatever, okay? Or I can use my fingers to slide up my view on the tablet and do stuff down here, like a set of axes, what have you. Ooh, that was weird. Let me get rid of that last thing there. No, it's acting a little clunky. There you go. So there's a set of axes and whatnot. That's using my finger. It might be a little bit better to use a little stylus. So let me try a capacitive stylus. All right, so I'm zooming in the top left-hand corner of the screen. And let's see, I have a thick pen blue. Alrighty, I have a white background, no lines. That's not usually the default, but that's what I like. All right, so let's see, the integral from 0 to 1 under the curve y equals e to the x, or f of x equals e to the x, dx equals, that's a little crooked, but you get the idea. Now I'm sliding over with three fingers. I already pinched with two fingers. Now I'm using, I could use one finger or the stylus to write. Let's see, e to the x from 0 to 1 equals, let's see, sliding around with three fingers, equals e to the 1 minus 1, sliding up. You don't see that, this is on my droid, equals is approximately equal to, that's the exact answer, isn't it? Let's see. Whoa, what happened there? Why is it stuck in that part of the screen? Wait, I need, where's the eraser? Get rid of the eraser there, put that back on, that's on, that's on, that's on, okay. Alrighty. That's still crooked. Why am I? I'm not used to this stylus yet. I was doing this all summer. It takes a little getting used to. All right, here we go. Not close enough. Approximately 1 point. What happened there? 1.718. Ta-da! All right, so I'm still getting used to this tablet thing. I can just use the smartboard if I want, but what's nice is the way I have my room set up is I code a lot in the back in Java or Sage or what have you, and I can see that the students are on task because all their monitors are facing me, and so is the smartboard. So it's a nice place to be in the back of the room, or I could be anywhere in the room and write on my droid. Okay, now what else do we have on here? So that's let's see, Firefox. I got Edmodo, which is sort of like a private Facebook page for your classes. I got Sage Online. I got the blog. I got my Dropbox. I got my screencast-o-matic. Here I've got my eSchool and other stuff. It doesn't really matter much. You got your Journal. You got your TeamViewer. Now, what else do we got here? Well, this is what's installed on the student stations too. I could run a T83 if I want. Here it is, and do the same problem. Let's see, what is math? 9 is the function numerical integrator of e to the x with respect to x from 0 to 1, and we get the same answer, 1.718 if we round off to 3 places. That's as good as the calculator can do. Well, I could graph it. Let's see, let's graph this. E to the x, it's all numerical, graphical on the T83. And how about a zoom 4? There it is. And then if you do second trace, what I call super trace, choice 7, I can graphically do the same thing I did a minute ago. 0, enter, 1, enter. So we're finding that area, and it's about 1.718 again. See? Very nice. All right, so let's exit that. I could do the same thing on the T89, but what's nice on the T89 is you could do algebraically. Get exact answers if you want on a computer algebra system. So second 7, e to the x, with respect to x, I could actually get an algebraic answer for the antiderivative. There it is. Or from 0 to 1 still gives me an exact computer algebra system answer. Or diamond enter gives me a decimal, right? There you go. So 1.718. We can also do this in Sage. This is how we run Sage. We start a terminal, and we can stay in the terminal. We could just say, okay, integrate e to the x with respect to x. And what happened? Bash error. Oh, I'm sorry. I didn't start Sage yet. Sage. There you go. Come on, Sage. Okay, so integrate, quantity e to the x with respect to x. I think I can give you an algebraic answer like the T89 did. There it is, e to the x. Can you see that? Let's make it a little bigger. Try that again. There you go. And maybe even bigger. All right. Or numerically, from 0 to 1, but that will also give you an exact answer if possible. Or numerically, that was algebraic, now this is numeric. And if you want more digits, you can ask for them. Digits equals, I don't know, 100 or 1,000. Right, there you go. Or you can plot it. Plot e to the x. And let's see what we get. This plot defaults to an x-min of -1 or an x-max of +1, so it goes from 0 to 1. There you go. X out of that, you get a little more crazy and do comma, I don't know, from 0 to 2. There you go. Now look, the aspect ratio isn't nice. 2 units is really wide here, 2 units is not so long here. And let's say you want a different color for each curve. Say you have multiple curves. What do? Well, you could do this, comma, color equals, I don't know, red instead of blue. There you go. And the aspect ratio is still off, so let's fix it. Comma, aspect ratio equal to 1. There you go. Nice. You can also do 3D graphs, I think. Let's see. What if I made A equals a vector that goes from 0, 0, 0 to 1, 2, 3, let's say. If I display A, it just does that. Let's say B equals a vector. Let's see, how about 2, 5, -3, say. And display B, okay. What if I said C equals A plus B? And let's see what C is. So let's see, did it do it right? 1 plus 2 is 3, 2 plus 5 is 7, 3 times 3 plus -3 is 0, perfect. Now what if you want to plot that? Let's see, I think you could do this. A dot plot, what does that do? Doesn't like it. Why not? Oh, did I spell it wrong? Dang it. Plot. Come on. Where are you? It's not plotting my 3D graph. Why not? Is that strange? All right, let's try this. If I X out of here, I could also run Sage this way. Sage-N gives you a GUI or notebook paradigm. Alrighty, there you go. Let's create a new worksheet. See, I already had one. Let's delete that. New worksheet. Let's call it midterm week 2. There you go. Now, wait, what is this? What is this? Wait, quit. Delete this. New worksheet. There you go. Midterm week 2. There you go. All right. So let's say I make A equal to a vector with the components. Delta X is 1, delta Y is 2, delta Z is 3. And I want to display that. Display A. There you go. All right, let's make a vector B equal to vector quantity components 3, 5, -1. And I want to show, see, look what happens if I show B, that's all you see. If I want more than one output per cell, that's another cell, that's the first cell, right? I need the show command, so show that and show that, and you'll see both. There you go, perfect. Now what if I make C equal to the sum of A plus B and show C? Show C, and there's your vector arithmetic. So 1 plus 3 is 4, 2 plus 5 is 7, and 3 plus -1 is 2, perfect. But now what I want to do is A dot plot it. There you go, nice, perfect. If you click interactive, it uses JRE to make this something that you can spin around and look from all different angles, but my JRE isn't quite running yet, so let's not do that just right now. All right, now let's say I make, what if I do plus another plot, B dot plot. Come on. Ta-da. Now, so that you know which is which, let's make this one red. Come on. Let's make this one green. And then the answer, let's leave it in the default blue. So plus another plot on the same graph paper, 3D graph paper, C dot plot is going to stay blue. And now what you're going to see is a version of the law of the parallelogram that the resultant, or the sum of two vectors, is the diagonal of the parallelogram made up of the two vectors when they're adjacent. Think of a parallelogram in 3 space, and there's the diagonal, the resultant. Perfect, very nice. All right, so just showing off what we got on here. So we did Sage, we used this in case we forget our trig values. The unit circle is nice, sort of an old-fashioned pencil and paper calculator. So we got Sage, we got trig, we got TID9, a computer algebra system like Sage. We got TI-LEM, which is the TID3 emulator. And I think that's everything. There's VLC if you want to play an MP4 file or DVD. There's Pandora if you want to play music in the background while students are working on exercises in groups or whatever. There's YouTube for my YouTube Wednesdays. I could do that in the browser, but Firefox downloads this for me, so it's quick and easy to use. And that's it. That's the whole setup. I think you got everything. What's going on here? I'm going to X out of this. Goodbye. And that's my background. That's a bash script to start my screencasting. This is just for my substitute assignments, and that's it. Everything's done. Good, we're done. So let's say, let's see, what is this? This is that. Let's say goodbye, YouTube. Have a nice day. Thanks for coming.